Hi, this is N. Shabana Sultana, working as an associate professor in Cerebral Engineering College. Today, I'm going to discuss you about some of the examples, some of the important components of thermoplastic and thermoset plastics. Coming to the first thermoplastic or thermoset plastic, that is a PVC, that is a polyvinyl chloride. So it is a thermoplastic which is used mainly in the manufacturing of water pipes, and it is obtained from the ethylene and the salt of vinyl chloride polymerization. It is the best explored material in the world due to the serious scientific researches carried in order to dispose the accusation. So this is the structure of the polyvinyl chloride. This is a vinyl chloride. That means if the chloride is attached to the carbon-carbon double bond directly, is called the vinyl chloride. And number of these vinyl chlorides, which acts as a monomeric unit, which combine together and undergo the polymerization and forms this polyvinyl chloride structure. Coming to the preparation, it is best synthesized from the acetylene. This is a structure of acetylene, CH triple bond CH, which is made to react with the HCl, hydrochloric acid. Then one of the bond from the triple bond, it undergoes the cleavage and forms CH2 CHCl. That means this HCl will splits or it undergo ionization as H plus and Cl minus. And this double bond, it undergo heterolytic fission and the migration of the bond takes place any of these two carbon atoms. Suppose if the migration of these two electrons either to this carbon or to this carbon, because it is a symmetric compound. If the two electrons is migrated to this carbon will acquire the negative charge because both the electrons will come to this carbon and it bears the negative charge, and this carbon will acquire the positive charge. And coming to the HCl, it can be dissociated as H plus and Cl minus. This H plus electron, it is migrated to the carbon which bears the negative charge. And this Cl minus, it migrates to the carbon which bears the positive charge. So in this way, the vinyl chloride can be prepared, it can be synthesized from the acetylene as a starting material. And it is a commercial process in which the vinyl chloride can be synthesized. And it can also be prepared from ethylene, that is carbon-carbon double bond. It means two carbon, ene means double bond. In this preparation, the ethylene is taken as a starting material, and if it is undergo chlorination means it is an addition reaction in which the chlorine can be added to the starting material. Here also, one of the bond of the two double bonded, it undergo either the homolytic fission or the heterolytic fission. Homolytic fission, the mechanism takes place through the free radical, and heterolytic fission, the mechanism takes place either through the cationic or anionic mechanism. If it is undergo the homolytic fission, the two electrons present in the bond will breaks equally, and one electron is migrated to this carbon and one electron is migrated to this carbon. And chlorine, it undergo homolytic fission and forms a free radical. Two chlorine free radicals will be formed. And these two chlorine free radicals will be distributed uniformly to these two carbons and form this intermediate product, which on further which on further undergo heating at the temperature of 500 degrees centigrade. It removes the HCl. Dehydrohalogenation. The reaction is known as dehydrohalogenation. It removes this chlorine, and among these two hydrogen, one hydrogen is removed and forms CH2, double bond CH and CO. And the reaction is, two types of reactions are taking place in this mechanism. One is halogenation. And the first step, it is a halogenation, addition of halogens to this carbon, two carbon atoms. And the second step is dehydrohalogenation, removal of hydrogen as well as the halogen. So this is the second preparation. See here. Or commercially it can also be prepared from, see here. In this, the vinyl chloride monomer is prepared by cracking or by the reaction of 1,2-dichloroethane. 1,2-dichloroethane, it also undergoes dehydrohalogenation. That means HCl will be removed from the reactant or the substrate and forms vinyl chloride. And the vinyl chloride may also be produced by the addition of HCl to acetylene. Coming to the properties of the polyvinyl chloride. This polyvinyl chloride, it is a commercially or economically or chemically stable, and it is a neutral, and it is a non-toxic in nature. And the major benefit is of the polyvinyl chloride is its compatibility with many different kinds of additives, making it a highly versatile polymer. And it has a very excellent insulating property, electrical insulating property. Insulation means the substance which does not allow the electrons to pass through it. The substance which does not allow the electron to pass through it. So this polyvinyl chloride, it is a very good electrical insulating property, and it has a good compact strength and impact strength, and it is also having the weatherproof attributes. Coming to the uses, there are many uses are there of the polyvinyl chloride. The first use is There are two types of polyvinyl chlorides can be classified. They are unplasticized polyvinyl chloride and plasticized polyvinyl chloride. Plasticized polyvinyl chloride, if the polyvinyl chloride, if it is treated with plasticizer, plasticizers means it is a compounding of the plastic. It is a substance. Plasticizer is a substance which are used for the plastic to increase the flexibility, strength to the plastic. If this plasticizer, if it is added to the polyvinyl chloride, it is known as plasticized polyvinyl chloride. And it is used for the electrical insulations, injection molding articles like the tool handles, radio and telephone components. And it is also used for the preparation of the chemical containers and the foam used in the buildings, cameras, and aircrafts. Whereas unplasticized polyvinyl chlorides, it is a rigid, highly resistant, and it is a brittle. This unplasticized polyvinyl chloride, it is used in making the safety helmets, refrigerator components, tires, cycles, and motorcycle mudguards. It has advantage over the polyvinyl chloride in that it offers a less resistance to flow than the conventional pipes, resulting in the minimum flow loss. This is achieved by manufacturing process that results in the smooth inner walls and is also used for the manufacturing of the frames for the doors and windows and is also used in making the electrical and telephone cables, sewer pipes, and portable water supply. And coming to the applications, unplasticized polyvinyl chloride is used for the construction and is also used for flooring, pipes, covering, cables, wheel frames, and it is also having the weatherboarding. So coming to the structure, it is a linear polymer and thermoplastic in nature, and it is having the property of white brittle solid, rigid material with a characteristic tendency to stick to metallic surfaces. And in the polyvinyl chloride structure, it is having the chlorine, which the composition is 56.8%. And coming to the solubility, it is insoluble to all the hydrocarbon solvents. And there is a few solvents for polyvinyl chloride, like cyclohexane and tetrahydrofuran. And the polymers as produced commercially is amorphous in nature. It is having the melting point of about 212 degrees Celsius. Coming to the glass transition temperature of polyvinyl chloride is 80 degrees centigrade. And the density is 1.38 grams per centimeter cube. Coming to the electrical property, polyvinyl chloride is a very good insulating property. As already told you that insulation means the substance which does not allow the movement of electrons to pass through it. But because of the higher polar nature, the electrical insulating property is inferior to the non-polar polymers such as polyethylene and polypropylene. And coming to another electrical property, it is generally suitable for the medium or low voltage and low frequency insulation material. Coming to the thermal property, This polyvinyl chloride, if it is treated with the heat, the stability is very poor. That means it is unstable to heat. When the temperature reaches up to 140 degrees centigrade, this polyvinyl chloride, it starts decomposing and converts into the vinyl chloride monomers. It decomposes and forms the vinyl chlorides. The chain of the polyvinyl chloride is broken when it is reaches to the temperature of 140 degrees centigrade. It is very unstable to heat. Coming to the weather stability, this polyvinyl chloride is resistant to aggressive environmental factors and is therefore it is a material of choice for roofing. Coming to the fire protection, this polyvinyl chloride is a material resistant to ignition due to its chlorine content. And coming to the life of the polyvinyl chloride, it lasts up to 100 years and even more. That means it is the longevity of the polyvinyl chloride is more. And coming to the hygienic property, this polyvinyl chloride is a material of choice for medical applications, particularly blood and plasma storage containers. That means this polyvinyl chloride is used for the storage of the blood and the plasma. And this polyvinyl chloride is used in packing of the foodstuffs and pharmaceuticals. So this is about the polyvinyl chloride. Next, coming to the another example, that is the bakelite. This bakelite is also example, or it is also important thermoset plastic resin, and it is named after the scientist Beckline, who synthesized this resin in the year 1909, which I am going to discuss in the next lecture. Thank you.